Question 31. An elevator is descending with uniform acceleration. To measure the acceleration, a person in the elevator drops a coin at the moment the elevator starts. The coin is 6 feet above the floor of the elevator at the time it is dropped. The person observes that the coin strikes the floor in 1 second. Calculate from these data the acceleration of the elevator. Solution. As the elevator descends with uniform acceleration, A, the coin has to move more distance than 6 feet or 1.83 meters to strike floor. Time taken equals t equals 1 second and initial velocity equals u equals 0. Acceleration of coin with respect to lift equals acceleration of coin with respect to earth minus acceleration of lift equals g minus a equals 9.8 minus a. Height of the coin from elevator floor equals 1.83 meters. Using relation, S equals ut plus 1/2 at squared, where a equals acceleration of coin with respect to lift, gives 1.83 equals 0 plus 1/2 multiply 9.8 minus a. A equals 6.2 meters per square second. Question 32. A ball is thrown horizontally from a point 100 meters above the ground with a speed of 20 meters per second. Find A, the time it takes to reach the ground, B, the horizontal distance it travels before reaching the ground, C, the velocity, direction, and magnitude with which it strikes the ground. Solution. A ball is thrown horizontally from a point 100 meters above the ground with a speed of 20 meters per second. It is a case of projectile fired horizontally from a given height. Here, h equals 100 meters, g equals 9.8 meters per square second. A, time taken to reach the ground equals t equals square root 2h by g equals square root 2 into 100 by 9.8 equals 4.51 seconds. B, horizontal distance traveled by the ball, x equals ut equals 20 multiply 4.5 equals 90 meters. C, horizontal velocity remains constant throughout the motion of the ball. From the figure, at point A, velocity along x-axis vx equals 20 meters per second and velocity along y-axis Vy equals u plus at equals 0 plus 9.8 multiply 4.5 equals 44.1 meters per second. Now, resultant velocity equals v equals square root 44.1 squared plus 20 to the power of 2 equals 48.42 meters per second. Let beta be the angle. Then tan beta equals Vy by Vx equals 44.1 by 20 equals 2.205, or beta equals tan inverse 2.205 equals 66 degrees. Therefore, the ball strikes the ground with a velocity 48.42 meters per second at an angle 66 degrees with horizontal. Question 33. A ball is thrown at a speed of 40 meters per second at an angle of 60 degrees with the horizontal. Find A, the maximum height reached, and B, the range of the ball. Take G equals 10 meters per square second. Solution. A ball is thrown at a speed of 40 meters per second at an angle of 60 degrees with the horizontal. Here, initial speed of the ball equals u equals 40 meters per second. Angle of projection of the ball with the horizontal, say theta equals 60 degrees. Also, A equals G equals 10 meters per square second. A, maximum height reached by ball. H equals u squared sin squared theta by 2 grams equals 60 meters. B, range of the ball. R equals u squared sin 2 theta per gram equals 80 root 3 meters. Question 34. In a soccer practice session, the football is kept at the center of the field, 40 yards from the 10 feet high goalposts. A goal is attempted by kicking the football at a speed of 64 feet per second at an angle of 45 degrees to the horizontal. Will the ball reach the goalpost? Solution. Initial velocity equals u equals 40 meters per second. Angle of projection equals theta equals 60 degrees. And A equals G equals 9.8 meters per square second. Now, maximum height, say H equals U squared sine squared theta by 2 grams. H equals 60 meters. And horizontal range, R equals U squared sine 2 theta by G equals 80 root 3 meters. Question 35. A popular game in Indian villages is goalie, which is played with small glass balls called golas. The goalie of one player is situated at a distance of 2.0 meters from the goalie of the second player. This second player has to project his goalie by keeping the thumb of the left hand at the place of his goalie, holding the goalie between his 2 middle fingers and making the throw. If the projected goalie hits the goalie of the first player, the second player wins. If the height from which the goalie is projected is 19.6 centimeters from the ground and the goalie is to be projected horizontally, with what speed should it be projected so that it directly hits the stationary goalie without falling on the ground earlier? Solution. The goalie of one player is situated at a distance of 2.0 meters from the goalie of the second player. Horizontal range equals R equals 2.0 meters. Let H be the height from which the goalie is projected by the second player equals 19.6 centimeters or 0.196 meters. As goalie moves in projectile motion, its acceleration due to gravity is A equals G equals 9.8 meters per square second. Now, S equals H equals U plus half a gram T squared. Here U equals 0, as the initial velocity in vertical direction is 0. Gives T equals square root 2H by G equals 0.2 second. Let goalie is projected with the horizontal velocity U meter per second. Then the horizontal range, R is R equals UT, or U equals R by T equals 2 upon 0.2 equals 10 meters per second. Hence, second player has to project the goalie with a speed of 10 meters per second to hit the goalie of the first player.